Ozar presents The Hidden Cost of Overrushed Innovation. In this presentation, we'll explore how the tech industry's drive for rapid iteration and short-sighted releases creates a hidden cost, the erosion of software stability. We'll examine the consequences for users and developers, with a focus on the dependency cascade crisis. And then, we'll introduce some possible solutions, such as the Software Stability Index Initiative.
Here's a question that's been keeping many developers up at night. What happens when the pace of innovation becomes so rapid that it actually destroys the foundation we're trying to build on? We've all been sold on the idea that faster innovation is always better, but there's a hidden cost that's breaking our entire developer ecosystem, and it's time we talked about it. The obsession with rapid development cycles is creating hidden costs that are systematically breaking the ecosystem we all rely on. All this rapid iteration and frequent yet short-sighted releases has created an unintended consequence that extends far beyond frustrated end users. While companies like those in FANG or FANG have been rightfully criticized for using customers as unofficial beta testers, there's an even more insidious problem brewing in the development ecosystem itself, one that turns professional developers into unpaid maintainers of an increasingly unstable foundation. To analyze the causes of the issue at hand, let's take a look at the dependency cascade crisis. As a former software development consultancy, we've worked across many platforms, using Swift for apps on Apple devices, C# for Windows applications, Python for data science and machine learning, Java and Kotlin for Android development, and various web technologies. These include Spring with Java, ASP.NET Core with C#, Django with Python, React and Angular with JavaScript, CodeIgniter and Laravel with PHP. In short, a diverse set of platforms. Over the years, we've seen a common issue repeatedly disrupt not only the user experience, but also entire development workflows. We call this problem stability erosion through dependency cascades. It's a growing sign of how the fast-paced release cycles of major tech companies can send shockwaves through the wider developer community. I'll give several examples to this, starting with JavaScript and Node.js, the poster child for instability. Consider this all-too-common scenario. You build a Node.js application using React, Next.js, Angular, Vue, or Svelte, iteratively adding features and NPM dependencies as needed. The project works beautifully, until it doesn't. Months, if not weeks later, a critical dependency gets deprecated, removed, or updated with breaking changes, rendering other dependencies incompatible and breaking your entire project. The severity becomes apparent when even AI assistants like ChatGPT, Claude, or Gemini cannot resolve the issues because the breaking changes fall outside their training data. Traditional resources like Stack Overflow, Reddit, Udemy, and LinkedIn Learning become obsolete overnight, leaving developers stranded with no viable solutions to previously solved problems. So what about Python, the most popular language ever with which you can create, well, almost magic? It even have a mechanism to lock versions of libraries you use in your program. But this is where fixed versions aren't actually fixed. The Python ecosystem presents another concerning example. Developers invest significant time in web tutorials, forums, YouTube videos, and even paying for e-learning courses to build AI-powered applications, including TTS systems, image generation, classification models, and RAG implementations for data synthesis. Despite using fixed Python versions and requirements.txt files with absolute version numbers, projects break due to dependency changes that cascade through the entire stack. The fixed versions become meaningless when underlying dependencies introduce breaking changes that weren't accounted for in the original dependency resolution. Okay, onto other examples. One particularly striking example of destabilization in the development ecosystem was the early evolution phases of Swift, Apple's programming language for iOS and macOS development. When Swift was introduced, it dramatically transformed the developer landscape, enticing a plethora of programmers who prefer relatively simpler languages with automatic memory management. With its modern syntax and safety features, Swift was far preferable to languages like C, C++, and Objective-C. However, the excitement about Swift quickly turned sour, following the substantial breaking changes introduced in Swift 2.0 and then again in Swift 3.0. Many seasoned developers found themselves frustrated as they grappled with the new complexities that came with these updates, leading to a notable exodus from Swift. While the language has supposedly stabilized since version 3.0, providing Swift 4, 5, and 6 with backward compatibility. The initial trauma left many disillusioned developers unwilling to return. Swift has struggled to maintain its position among the top programming languages, often slipping out of the top 5 and even failing to capture the enthusiasm it once had. Another troubling instance was with the Angular framework, which faced considerable user pushback due to its frequent major updates. Infamous for its breaking changes, Angular has seen its community shrink somewhat, due to developers seeking more stable alternatives. As companies continue to push for rapid advancement, the pull for developers to switch to frameworks that offer a more stable environment, such as React and Vue.js, has intensified. Similarly, ASP.NET Core has faced similar criticism for its relentless delivery cycles that have driven away engagement and growth within its developer community, affecting its ability to attract new talent and projects. Overall, these examples underscore a broader pattern of breaking changes across various languages and frameworks that have disrupted developer workflows. From Swift's tumultuous introduction and Angular's frequent upheavals to the chaos created by multiple confusing ECMAScript iterations, developers often find themselves navigating a minefield of changes that can upend established practices. With the rise in dependency and compatibility, as seen in the Python ecosystem, and the over-engineering in frameworks like SwiftUI, it becomes clear that maintaining stability is a critical but frequently overlooked aspect of a language's evolution. Developers are left grappling with uncertainty in their tools, which not only frustrates productivity, but also takes away from the overall joy and creativity that coding can bring. This scenario serves as a stark reminder that while progress is essential, it must be balanced with a commitment to stability and community feedback. So, what is the real cost to professional development? This issue goes beyond the consumer beta testing problem highlighted in the original analysis of tech giants' release strategies. While end users face productivity losses and frustrating experiences, developers face an existential challenge. We're becoming unpaid maintainers of an increasingly unstable foundation. Every innovation cycle forces developers and the LLMs they use for coding to rebuild previously functional applications, retrain on new paradigms for solved problems, rediscover solutions to issues that were already supposed to have been addressed, and absorb the hidden costs through lost productivity and technical debt. Next, there is the vendor lock-in strategy. Some tech giants even benefit from this chaos in several ways. Forced migration. Breaking changes drive adoption of newer services and platforms. Consulting revenue. Companies profit from selling solutions to problems they created. Subscription models. Instability justifies moving to managed services and cloud platforms. Competitive moats. Smaller competitors can't keep up with the constant churn. And then there's the psychological toll on developers. A truth nobody wants to discuss. Many developers enter the field with curiosity and a strong desire to learn and contribute added value to the projects they get involved in. However, the psychological impact of the industry's relentless pace of breaking changes often hampers their professional growth. This cycle not only affects their skills, but also leads to burnout, diminishing their care for code quality due to the knowledge that their work may be undermined by changes beyond their control. For those in smaller teams, the challenges posed by these breaking changes can feel particularly isolating. When team members are few, the burden of keeping up falls heavily on individuals, making the struggle for continued learning even more pronounced. Time spent mastering a framework can be wasted when arbitrary changes render that knowledge obsolete. This leads to a phenomenon known as learnt helplessness, where developers become cynical about further deepening their expertise. The industry's mantra of continuous learning feels disingenuous when efforts are consistently undone by irresponsible release practices. Developers trying to stay current often feel like they're running on a treadmill that speeds up year after year with little genuine advancement. This isolation and the pressure of constant change not only affect individual morale, but also threaten the cohesion and effectiveness of the entire team. But wait, does AI not come to the rescue? While AI technology, particularly in the form of large language models, has proven to be a valuable tool in the coding landscape, it is concerning that many employers are overestimating its capabilities. This over-reliance eventually leads to a reduction in the number of developers on teams as businesses place a greater emphasis on leveraging AI for programming tasks. Although LLMs exhibit impressive coding abilities, they also face significant limitations in the current environment, which is dominated by the aforementioned over-frequent breaking changes. Many stakeholders remain unaware of the higher costs associated with operating these models as is, or retraining them just to keep up with this relentless introduction of numerous breaking changes within programming languages, ecosystems, frameworks, and SDKs. These ultimately render LLMs inefficient, if not counterproductive as well. What's even worse is that the irresponsible pattern of introducing breaking changes under the guise of progress often results in little to no actual value, adversely impacting LLM performance. This also proves that the perception of efficiency and cost savings by stakeholders and employers is a misled outcome. Without a widely accepted and established framework, such as the Software Stability Index, SSI, or a similar methodology, even AI cannot effectively address the fundamental issues within the development ecosystem. Instead, it risks perpetuating a cycle that offers only a false sense of security, ultimately failing to resolve the instability developers face. Now it's time to talk about some possible solutions. Measuring the unmeasurable software stability. The concept of quantifying software stability isn't new. Traditional approaches like architectural health metrics focus on system stability by measuring how sensitive systems are to changes and how their dependencies relate to each other. If you want to learn more about this, you can search for Lattice Architectural Health Metrics online. Meanwhile, the DevOps Research and Assessment Framework, commonly known as DORA, provides 4 key metrics for evaluating how well teams deliver software, how often they deploy, how long changes take, how often changes fail, and how quickly they recover from problems. You can find detailed information by searching DORA Metrics DevOps if you're interested in diving deeper. However, these established frameworks primarily address operational stability rather than ecosystem-level sustainability. Reliability metrics assess the likelihood that a system will perform its intended functions without failure under specific conditions. For a comprehensive overview of this topic, try Googling Essential Reliability Metrics Software Quality. Still, these metrics don't capture the broader ecosystem challenges developers face when dependencies become obsolete or incompatible. Component dependency metrics measure how tightly coupled software components are and how densely they interact with each other. You can find academic research on this by searching Component Dependency Metrics Software Systems. Yet these approaches all focus on internal system architecture rather than external dependency chain stability. With the goal to stabilize the craft of software development while taking into account the pros and cons of existing methodologies, we've started a work titled Software Stability Index, which is a framework for measuring the impact of software changes on existing implementations across the broader ecosystem. This approach extends beyond traditional stability metrics to evaluate framework reliability through breaking change frequency, documentation persistence, community resource longevity, and dependency chain stability. Our Software Stability Index methodology provides a framework for measuring the impact of software changes on existing implementations. There is now even a GitHub project offering practical tools for tracking these metrics, which becomes increasingly relevant as we face widespread ecosystem instability. Building on this foundation, we could establish framework reliability ratings based on the following. Breaking change frequency. How often do updates introduce incompatible changes? Documentation. What percentage of tutorials and guides remain valid after 12 months? Community resource longevity. How quickly do Stack Overflow answers become obsolete? Dependency chain. How often do transitive dependencies cause project failures? And we can consider this a call for stability standards. The development community needs to collectively push back against the normalization of breaking changes disguised as innovation. We should demand thoroughly thought inventions, designed to last, not deprecate. All programmers should think thoroughly when designing a feature. Aim to improve and innovate without compromising the foundation in the first place. The higher the goal, the greater the added value, and the fewer the side effects. Backward compatibility. Frameworks and SDKs should provide clear timelines for deprecation, along with adequate migration paths that are followable by both humans and LLMs. Stability ratings. Public metrics tracking how often platforms break existing code. Educational resource protection. Consideration for how changes impact learning materials and documentation. True semantic versioning. Honest version numbering that reflects the actual impact of changes. Preference of stable tools. Prefer languages, frameworks, SDKs, IDEs, and platforms with high SSI ratings over others. Avoid ones with volatile dependencies. So, where do we go from here? The rapid pace of technological change isn't inherently problematic. Innovation drives progress. The current approach focuses more on feature velocity than on ecosystem stability, which imposes a hidden cost on the entire development community. To achieve a better balance between innovation and reliability, we should adopt tools like the Software Stability Index and encourage providers of SDKs, frameworks, and platforms to improve their practices. The cost of moving fast and breaking things is ultimately borne by the developers, communities, and businesses building on these platforms. It's time we started accounting for that cost and demanding better from the companies and communities that profit from our dependency on their tools. More importantly, we need to recognize that this isn't just a technical problem. It's a human one that affects the very people who build the software our economy depends on. We are wondering, what frameworks and platforms do you consider most reliable based on these stability criteria? Have you experienced similar dependency-related project failures that could have been avoided with better release practices? Thank you for watching this video. If you found the insights valuable, please like the video and subscribe to the Ozar Digital channel for more content. For more information about software stability initiatives, feel free to visit www.ozar.net.